In the previous session, we have seen how to write a Verilog code and test bench for the transmission gates. In this session, we will see how to write a Verilog code and the test bench for all the gates. As we have seen from the previous semesters, the digital logic circuits, or we do call it as the gates, are represented as NOT gate. The digital symbol of the particular NOT gate, where we do have the input, a single input and a single output, and AND gate, a two input AND gate, let us define it as AB, output as Y, and OR gate, a two input OR gate, NAND gate, a two input particular NAND gate, NOR gate, a two input NOR gate, XOR gate, a two input XOR gate, and XNOR gate, a two input XNOR gate. So these are the digital logic circuits that we had studied in the previous semesters, and to write in Verilog code we need to define these basic digital logic gates in terms of the operators, how they would function. For the particular NOT gate, when we see the particular operation, we have told that input as A, output as B, we need to define which is B, the output, which is a complement of A. So this particular operator works as a complementary function. Next, for the particular AND gate, we do have Y as an output and A, which is ANDed with B. So this is a particular AND operator which we do define. Next, we do have output which is Y, and this is a particular OR function A, which is ORed with the B. Next, a NAND, which is a complementary function, which is A ANDed with B, which is a NOR gate. It is a NOR function. XOR gate, an operator which defines an XOR operation. And last, we do have the XNOR gate. Y equals a complement of the two variables of A and B. So this defines a particular XNOR operation. So we will write a Verilog code for this particular digital logic symbols, and we know that to start with a particular Verilog code, we need to start with the module name. Let us define the module name as gates with the ports list. We do have two inputs. Let us define as two inputs as A and B, and we'll do define it as the outputs. It is Y1, Y2, Y3, Y4, Y5, Y6 and Y7. We do have ports declaration, input as A and B. Let us define input as A and B, output as Y1, Y2, Y3, Y4, Y5, Y6 and Y7. We will use a continuous assignment statement which is assigned to define the values on a net, and it is used in terms of a data flow description model. So we'll use a continuous assignment statement assign. For a NOT operation, we'll just take the output as y1, and again which is a complementary functions, we do have a single input, let us say, which is complement of A. First operation. Next we do have the AND operation, A ANDed with B, assign. A NOR operation, y3, A ORed with B, assign. A NAND operation, A ANDed with B, which is a complementary function, assign. A NOR operation, y5, A ORed with B, assign. y6, it is an XOR operation, assign. y7, which is in terms of the particular XNOR operation. So we are ending the module with the particular end module. So the program that is written, it is in the data flow description. As you can see, we do have a continuous assignment statements, and next we will write the particular test bench for this all gates, where we do have digital symbols or we do have a particular digital logic. Again, the particular test bench will start with a Verilog code with the module and module name, which is gates underscore TV. Will define the input in test bench. It is defined as registers, which holds the value of a particular variable, and we do have two inputs, which is in terms of A and B. Next, a wire which defines the value of a variable on a net to the particular output, which carries the values to the particular output, which is wire y1, y2, y3, y4, y5, y6, y7, and we are interlinking the Verilog program with the particular test bench of the inputs and the particular outputs, which is called as UUT or unit under test, which is UUT. Let us define the inputs A, B, outputs, it is y1, y2, y3, y4, y5, y6, and particular y7. Next, it is the initial begin, where we do define the particular inputs. Let us define A equals 0 and B equals 0 for 10 nanoseconds, A equals 1, B equals 1 for 10 nanoseconds, A equals 0, B equals 1 for another particular 10 nanoseconds, A equals 1 and B equals 0 for the particular 10 nanoseconds, A equals 1 and B equals 1 for the particular 10 nanoseconds, A equals 0, B equals 1 for the particular 10 nanoseconds, A1, B0 for the particular 10 nanosecond. So, the inputs with respect to the particular variables are defined. Next, we need to end the particular initiation of the inputs, and we need to end with the end module. So, this is the test bench for the particular all gates. So, we have written a Verilog code for the all gates, and to simulate this particular program of all gates, we are writing the test bench which defines the functionalities of the particular all gate. So, we have defined the inputs. Depending upon the values of the inputs, the output is obtained through the simulation window.